My name is James Hart, Australian Panel Convener for C3 Power System Environmental Performance. The purpose of this presentation is to provide an overview of the key activities undertaken over the last 12 months. The scope of C3 includes the identification, assessment and management of the various impacts on the natural environment arising from electrical power systems. C3 currently has 11 active working groups and 1 reference group. Some of the key themes throughout these working groups is climate change, public acceptance, and interactions between wildlife and the network. One of the working groups is looking at practices for improving public acceptance of substations. Key factors in terms of public acceptance include appearance, so whether it be trying to hide the substation or camouflage it or even promote it, compatibility with land use, safety considerations, whether it be actual or perceived, emissions such as noise, EMF, SF6 and oil, ecological and cultural heritage impacts, and community engagement. Some case studies used in the technical brochure include a substation at Norway, one at Sweden where they're trying to promote the substation, in Argentina where they're trying to obscure the switchyard, and in Switzerland where they've attempted to integrate the substation into the landscape. In France, in this case, there was an archaeological area. They preserved a number of relics and the public can come and view these relics. In the US, they integrated a public walkway around the substation, a viewing platform and a dog park with the aim of promoting it as a public gathering area. And in Germany, they've used reflective materials and chosen colours to blend in with the background. The working group is due to finish their work next year, and it should provide some valuable insights into how to better integrate substations into both the environment and into our communities. The bulk of my C-grade time over the last 12 months has been taken up completing a technical brochure on the responsible management of the EMF issue. Last year we ran 2 webinars, one for an Australian audience and one for an international audience. The brochure was published in June of this year, and in August we ran a C-grade tutorial. Feedback on the brochure since publication has been very positive, and I think that reflects on the value of C-grade. This brochure would not have been possible without experts from around the world who are willing to share their knowledge and contribute to a brochure which has proved valuable to industry and should remain so for years to come. An example of how the brochure has helped locally concerns compliance in close proximity to heavily loaded cables. You'll see here for a 1000 amp cable, we've exceeded the occupational limit if we approach closer than 20 centimeters to the cable. Now when the standard came out, the regulator at the time said that we could adopt higher limits. However, these would have to be based on induced internal electric fields. Unfortunately, they weren't able to provide any guidance on how we'd go about that, and there was limited expertise in Australia. At the time, the standards in Europe became law, and there was subsequently a lot of work done to demonstrate compliance around this particular issue. And these learnings have been incorporated into the technical brochure. You'll see that there are in fact quite a few limits, some of which are based on the work done in Europe. If we look at an occupational type example, the limit to select will depend on which standard we're adopting, whether the head is exposed or the limbs or the whole body, and also the degree of awareness of the worker. In this particular case, we'll assume it's the whole body, and so we've got 3 potential limits. In this example, we'll assume a cable radius of 4 centimeters. We've also got separation distances due to the skin and the brain and the helmet, and this gives us a minimum approach distance to the center of the conductor of both 8 centimeters and 5 centimeters. The differences in these numbers is described in the technical brochure. However, it results in a situation where for a 400 amp conductor, we're intrinsically compliant against the 1 millitesla limit, and for a 1000 amp conductor, we're intrinsically compliant for the controlled environment limit. This controlled environment limit does require a greater degree of awareness for workers. SF6 is part of the broader discussion around climate change. And like EMF, it's important to consider the science as a whole, rather than the results of individual studies or opinions. The relevant authoritative review panel in relation to climate change is the IPCC. The IPCC is saying that we need to keep temperature rise to below 2 degrees by the end of the century to avoid ecological transformation. If we increase above this, there's also the possibility we may get self-reinforcing feedback. This conclusion formed the basis of the Paris Agreement, and it forms the basis of the collective agreements amongst the participating countries to achieve that goal. As we heard during the e-session this year, unfortunately, the world is currently not on target to achieve those levels, and the same can be said for Australia. So there's quite a bit of work still to do. SF6 is one of the most potent greenhouse gases with a lifetime of over 3,000 years. As an example, this network operated in Australia, SF6 accounts for 1.6% of its Scope 1 and 2 emissions, which are those required to be reported under the NGES scheme in Australia. If we looked only at Scope 1 emissions, that contribution would be about 40%. In addition, we've got other countries and areas which have either legislated a phase out or are debating a phase out. While this may not directly impact Australia, it may influence our politicians and it may affect the supply chain. In Australia, we've got a lot of uncertainty around climate change policy, and this also adds to the risk. And finally, we're seeing increasing demands from shareholders and investors to do more about climate change. In terms of what we can do to reduce SF6 emissions, we can start the transition to phase out SF6. There are alternatives available, and these are becoming more competitive. We can look at ways to reduce leaks and reduce repair times, and we can improve reporting. The most common method is Tier 1, which assumes a leak rate based on a total population. The method is very blunt and conservative. The Tier 2 method is based on mass balance, which can be sensitive to errors. For example, an unaccounted for cylinder could result in an assumed leak of up to 100 kilograms. And the Tier 3 method is based on measuring the actual leaks. For a company with thousands of pieces of equipment, this can present a challenge. In my company, we are trialing an app whereby the worker will scan a QR code on the cylinder. It brings up details of that cylinder, and they enter the weight before and after carrying out an activity. The app will then identify if it's a leak and notify the environmental team, or it will identify if they've missed a weigh and it will notify the user. It will also identify which pieces of equipment are leaking the most, and that will assist in reducing the number of leaks. Thank you